Dear students, we are going to look at a very important concept of vector calculus in this session, that is divergence of a vector function or a vector field. Divergence of a vector function. For example, we have f, which is f1 something I plus something another function j plus f3k. Then this dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is divergence. I'm not defining divergence, I'm just telling you what is divergence standing for. Is divergence of f and is denoted by div space f. This is the vector f, okay, or del dot f. Keep in mind, del is calculated for a scalar. This is grade phi, and del with the dot, and for a scalar vector function, this is divergence f, and del cross f, that is curl f. You can remember that this d for dot and d for divergence, this cross, c for cross and c for curl, like that you can remember. And these two are calculated for vectors, but the output is a scalar here and the output is a vector here, whereas the input is a scalar and the output is a vector in the case of gradient. So this is somehow a short recap of the earlier things which we have seen, and now we'll go in this video about what is meant by divergence. And let's have a very important touch of a concept, that is solenoidal vector. Note it that if del dot some vector a is equal to 0, then that vector a is called solenoidal vector. Solenoidal vector. We'll have a short touch of one problem if the question comes. If vector f, or I'll just change the name again, we have taken one f and a, I'll say just v is equal to some x square plus y I plus xyzj plus xy square k. If this is the vector v, then find divergence of this vector at 0, 1, 2. Some point is given. If point is given, we will substitute it, otherwise we just stop at that value. So given v is equal to some x square, or else I'll write it in the next line. Given, let me change the color. Given vector v is equal to x square plus yi plus xyzj plus xy square k. Divergence of this v is so simple. We are going to take dou by dou x of only this I coefficient. That I coefficient is x square plus y, and then add up the partial derivative with respect to y only, that is for only j coefficient, and then add up the partial derivative with respect to z only for only k coefficient, that is x y square. So the resultant scalar is called the divergence. Now with respect to x, that will become 2x, plus with respect to y, that xz is a constant, and with respect to z, x square xy square derivative is 0, so it is just x into 2 plus z. And Therefore, the value of divergence of the vector v at the point, some point is given, otherwise we'll just stop it here. So the point is given as 0, 1, 2, 0, 1, 2, that is equal to x value is 0, 2 plus 2, so finally it is equal to 0. Sometimes they give the problem if some vector a is equal to x plus y square I plus some, for example, 2y minus zj plus cz plus x cube k. If this vector is solenoidal, then find c. That constant c which is here, that c we need to calculate. So we need to find that value of c. So simple, what we do now is just given that a is solenoidal, given that vector a is solenoidal implies the divergence of that one del dot a must be equal to 0. But what is del dot a now? That is dou by dou x of x plus y square, dou by dou y of 2y minus z plus dou by dou z of the k coefficient, that is cz plus x cube, that must be equal to 0. Now the derivative for this first term with respect to x is 1 and it is 2 here, plus c, that's equal to 0, implies c is equal to minus 3. So c value is minus 3 when the vector a is solenoidal. I hope you have understood.